So good news, bad news. I don't know if it's good or bad for you. We're pretty much done with graphing for this chapter. Okay, I mean, it's still going to be on the quiz, it's still going to be on the test, but in terms of new stuff, we've done our graphing. We graphed solving systems of equations, so looking for where they crossed. Yesterday, you graphed solving systems of inequalities. With systems of inequalities, we were looking for where the shading overlapped. Okay, so today, lesson 3-2, we could probably try and get it all done in one day, but I'm going to split it into 2 days so that we can take time to practice one technique at a time. So today we are specifically practicing the substitution technique. Okay? Tomorrow we will get to the elimination technique. But today is just substitution, which, in all honesty, substitution is probably your less favorite of the two a lot of the times. Yeah. I think people usually tend to like the elimination better, which is a good reason for me to start with substitution. In all honesty, for me, it depends on what the problem looks like. There's times I like substitution. There's times I prefer elimination. Yes?
So does that mean the homework due tomorrow?
Two different homeworks. Okay. The homework, yes, okay, so valid question. The homework today will be lesson 3.2.1, as in part 1, which is substitution. There will be a separate notes tomorrow, separate homework, lesson 3.2.2, so part 2, which will be the elimination. Valid question that I didn't think to answer that way. Okay, guys, do you remember how substitution works? A little?
Isn't like elimination. Cancel out.
Right.
Elimination is when they're trying to list it.
Yeah.
Okay. Yeah, so to kind of separate them, elimination is the one, and that's what we'll talk about tomorrow, where the x's are lined up, the y's are lined up, we can eliminate one of either the x's or y's. Substitution, we need one of our equations to be solved for either x or y, so that we can then substitute it into the other. So in this case, in all honesty, if I looked at example 1, it's very possible I would actually do elimination with it. But it is also a very valid substitution problem. So look at example 1. Pick one of the equations that we want and solve it for either x or y. The bottom one, solve it for y. Okay? What? Why are you picking to solve the bottom one for y? Okay? Because it's just a 1y, right? It's probably our easiest bet to solving one of these. So, if we take our bottom equation, how do we solve that for y? We're going to subtract the 2x. If we subtract the 2x from the left, subtract the 2x from the right. I will zoom in some here. And so now I have y equals what? Negative 2x plus 10. That is one option. You could actually leave it as 10 minus 2x if you prefer today. Either way. Now, the idea of substitution. Using our other equation, every place we see a y, we're going to replace it or substitute it with negative 2x plus 10. So, using the other equation. My other equation is 3x plus 4y. What am I using for y? Negative 2x plus 10. And then that equation still equals 12. And I'm totally off the screen, aren't I?
Yeah.
Better? There we go. So I took that top equation, I rewrote 3x plus 4y equals 12, but instead of writing y, I wrote what y equals, and y equals negative 2x plus 10. From here, it's your equation solving steps. How do I solve an equation? Distribute. We see parentheses we want to distribute. Okay, let's do that. So 3x stays 3x. 4 times negative 2x minus 8x, 4 times 10. Plus 40 still equals 12. Okay. Ethan said distribute. Somebody else. What am I doing next? Okay, Dietrich says like terms. 3x minus 8x. What do we know about 3x minus 8x? Negative 5x. Still plus 40. Still equals 12. Notice I'm writing down my steps every time. Okay. Now, how do I solve for x next? Okay. So we're going to minus 40 here since it's negative 5x plus 40. I'm going to minus 40. Still negative 5x. 40 minus 40 cancels. 12 minus 40.
Negative 28.
Negative 28? Yeah, we all got the negative here, and we're all sitting here thinking, oh, what is it? And? Okay, if it's negative 5 times x, divide by negative 5. Options for how I can express this answer. Okay. As a fraction, what would I express this as? Okay, except what is a negative divided by a negative? Positive. So if you're going for fraction form, I would use positive 28/5. Could you go decimal form? For me, I don't care. You can go fraction or decimal. So some of you already have it, I guarantee. What is 28/5 as a decimal? 5.6. I will accept either or. Now, here's the key. Will Math Excel accept either or? Probably not. I honestly don't remember which they want. Yeah, they will be specific for you. Okay. Am I done?
Yes.
Okay. On Monday, when we were solving systems of equations, we were looking for whether the two equations crossed. And what kind of answer did we have when they crossed? Ordered pair, yes. It was x comma y. I know what x is, but I don't know what y is. So I'm not done. That is the biggest mistake we can make on these, is to stop after only getting one of your answers. How do I get the other answer? Okay, so take the answer we just got. Officially, it's plug it back into one of these equations. What I would say, though, you can use this variation of, we have a y equals equation here, right? That's your easiest place to plug it in. And so when I plug this in, it's y equals negative 2 times x. You can either use the fraction or the decimal. I have to ask, I know what you guys are picking. Negative 2 times 5.6 plus 10. Negative 2 times 5.6 is negative 11.2 plus 10, negative 1.2. Best practice. How do you write your final answer? Ordered pair. So, 5.6 comma negative 1.2. Okay. Math Excel won't really let you get away without it. When it comes to like a quiz or a test, I'm going to be looking for those ordered pairs. Did it come back to you a little bit? I don't know if it's a good flashback or a bad flashback, but it's a bad one because you guys are ready to, you prefer to do elimination? I'll be honest, I prefer elimination if it's set up nicely for it. If it's set up for substitution, though, I'd rather do that. So, and I'll be honest, these are kind of tricky because they're more set up for elimination than substitution, but either or. Okay, let's do the second example. G plus 3h equals 5, negative G minus 2G minus 4h equals negative 5. Nothing wrong with a lot of negatives. What's your first thoughts on this problem? Okay. Some of you are bugged by G and H? Okay, yep. So if you would prefer, you could make your first step of, instead of thinking, okay, I'm going to do x plus 3y and negative 2x minus 4y. That would make you happier, go for it. If you're fine working with the G's and H's, that's fine too. Just remember, alphabetical. So, now that we're past the G and H issue, what's your first step in substitution? Pick one equation and do what with it? Solve it for either x or y. Just depends on the situation. Which one would be easiest to solve in this case?
Top one.
Solve the top one for G, or in other words, what I'm going to call x. So since it was x plus 3y, we're going to subtract 3y. So I'm going to have the x is equal to, you can either say 5 minus 3y or negative 3y plus 5. Once you have one of your equations, either x equals or y equals, what's my plan? Plug it into the other equation. So in this case, negative 2x minus 4y equals negative 5. So what am I doing? Negative 2, what's x? Negative 3y plus 5. So there's my negative 2x, still minus 4y, equals negative 5. Do you know your steps? Okay. Distribute. It's typical equation solving, nothing fancy here. Negative 2 times negative 3y is going to be plus 6y. Negative 2 times 5 minus 10, still minus 4y, still equals negative 5. Okay. On the left, put the like terms together. Something I want to point out from chapter 1. Some of you guys goofed this up on chapter 1. How do I put that 6y and 4y together? Yeah. Use the symbols that are right there, yes? Do I try and do the opposite of things? Here's a big mistake, and some of you guys did it to me on chapter 1 test. To put the 6y and 4y together, some of you would say, oh, it's minus 4y, so I'm going to add 4y. Add 4y. Why do I not do that? They're already on the same side, yes? When they are already on the same side, you just put them together. You do whatever the signs tell you. If they're on opposite sides, that's when we have to do opposite. Okay, so this says 6y minus 4y, which is 2y. Still minus 10 equals negative 5. If it's 2y minus 10, add 10. This time we are trying to take to the other side, yes? So that's why we did the opposite. 2y equals negative 5 plus 10? 5. And to finish this off, divide by 2 And y is 5/2. 5 over 2. If that really bugs you, it is 2.5. Next problem. Okay, you have to find the other half of your answer, right? Don't stop there. Find the other half of your answer. Again, I would go back and use the equation that was x equals in this case. So x equals -3 times 2.5 plus 5. So -3 times 2.5 is -7.5 plus 5 is -2.5. Answer says ordered pair, -2.5, comma, +2.5. Remember, you're ordered in the ordered pair is x, y. Alphabetical. You struggle to remember what comes first. Ready to try a third example? We will skip a little bit, but I do want to do this one. Okay, you got your steps down? First step, take one of the equations and solve it for x or y. In this case, what's easier? The bottom one's probably going to be a little bit easier because it's going to work out, if you kind of look ahead, it's going to work out nicely, isn't it? Because how can I solve that bottom one for y? Divide everything by 2. Now, if we're going to divide by 2 and it's going to put fractions in our problem, I don't guarantee it's the best way to go. But in this case, it's going to work out nicely, so why not? Divide by 2. If you divide one side by 2, divide everybody by 2. So it becomes y equals 3x minus 1. And substitute into the other equation, right? So my other equation, -6x plus 2y, except y is 3x minus 1, still equals 8. Same old steps, right? -6x stays -6x. 2 times 3x plus 6x. 2 times -1 minus 2 equals 8. Okay, well, let's take the next step. Tell me officially what happens in the next step. Yeah. When you clean up like terms, -6x plus 6x turn out to be 0. They cancel. What part of my equation remains? -2 equals 8. Okay, and I always say when my variables cancel, I have two possibilities. No solution or all real numbers. What's that remaining piece tell me? Does -2 equal 8? No. So since -2 does not equal 8, that right there tells me this problem has no solution. Thus the reason I required us to do that one. Because we need to be reminded of what happens. And no solution means it doesn't matter what x values you put in. There is x or y values. There are no possibilities of anything that will work. Okay? And what it ends up meaning, what's the graph going to look like if there's no solution? Now? The lines are parallel, right? Those are parallel lines. They're never going to touch. It doesn't matter what you try. They will never touch. Okay. If you guys are okay with what we just did, we can skip the next example. Because if anyone's already worked it, I will tell you the next one also comes out to be no solution. So if you want to see an idea of how that works, you can. I do, however, want to do the bottom one. Okay, so let's look at the bottom one for a moment. Step 1. Take an equation, solve for x or y. And we're not crazy about any of these, are we? Okay, and that's the unfortunate part. I mean, they're kind of set up to solve for y, but you're going to have fractions no matter what. So in all honesty, it doesn't matter which one. Because both ways you're going to end up with fractions and have to deal with it. Okay? Top one? Okay, so if we take the top one, that is negative 3y equals 9x plus 1. In order to solve that, you're going to divide by negative 3. Okay? Y equals 9x divided by negative 3 is negative 3x. 1 divided by negative 3? Minus 1/3. Okay. We have to deal with that fraction. And guys, this is a fraction. Do not go decimals on this fraction. Because 1/3 is not a nice neat decimal. Okay? Yeah, and if you round that 0.3333 to 0.3, you've changed the meaning of the number. Okay? So do not round a decimal to make instead of using a fraction. Okay, guys. Did you plug it in? In the other equation, every place we see y. So if it's 6y, it's 6 times negative 3x minus 1/3 equals negative 18x minus 2. What is that step on the left? Distribute. Distribute property is actually going to be nice to us here. 6 times negative 3x, negative 18x. 6 times negative 1/3. What is a third of 6? 2, because 6 divided by 3 is 2. Now, officially, if you notice something right now, you can stop. I'm going to take one more step to kind of show you something. But officially, what are you guys already recognizing? Both sides are identical, yes? Now, take the step with me. If we're trying to get the x's on the same side, officially, what do? You add 18x. And when we add 18x to both sides, the x's cancel. You end up with negative 2 equals negative 2. So what happened? The variables, poof, gone, right? What do you know about the remaining statement? Negative 2 does equal negative 2. So last time it was a false statement, it was no solution. This time it's a true statement, and I used the words all real numbers at the time. I looked at my notes since. In the notes I actually have written infinitely many solutions. Okay, it's the same idea both ways. I think officially the infinitely many solutions is probably more appropriate here because in this case the solution is an ordered pair. And so a solution is not just a number. So it's a little more appropriate to say infinitely many solutions. But it's the same idea. What does this graph look like if there's infinitely many solutions? It's one line, right? Because these two lines are the same exact line. If we put those both in y equals mx plus b form, they'd be the exact same line. Okay? So, because this ended up being the same, I'm going to write infinitely many solutions. So it's not just that any number works, but there are an infinite amount of ordered pairs that work. I want to do one from the back. Okay? They really are very similar on the back, so I want to do one from the back, and then you guys can have your own time. Because, guys, is writing equations something we have to be able to do?
Yes.
It is. Whether we like it or not. It's one of the hard things about math. But it's a necessity. So, let's read the problem. The music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee are advertised as 6 lessons for $300 or 12 lessons for $480. What is the cost of each lesson and the one-time fee for materials? Now, I know some of you guys are already doing mental math. You're doing your own little way. I get it. However, I want to practice writing those equations with you right now. Okay? So, if we're writing equations, we need variables, yes? So one thing I'd like to ask myself is, what do I need variables for? What are the unknowns that I need a variable for? So I would go to my question. What's my question say? Okay, so what is the cost of each lesson? So that's going to be one of my variables, and I'm going to call that X. You can call it whatever you want. What's the other thing I need to know? The one-time fee for materials, and I'm going to call that Y. Okay. So that's my way of I look at the question. What are my unknowns? What do I need a variable for? Let's write an equation for each situation. The cost for lessons and a one-time fee are advertised as 6 lessons for $300. How can I write an equation with this, that 6 lessons for $300? Almost. The cost for lessons and a one-time fee are advertised as 6 lessons for $300. Right, because it's 6 lessons, right? So 6 times however much lessons are. But it also says, and a one-time fee is included in that. So my first equation, 6x plus y equals 300. And it's just plus y because it is a one-time fee. Do you know the other equation then? Okay, yeah. It just continues to say, or 12 lessons for $480, but based on the problem, what's included besides the 12 lessons? That one-time fee. So 12x plus y equals 480. So if you guys have learned the hard way, if my directions on a problem say write the equations, you will lose points if you don't write the equations, right? That was a chapter 1 thing. So beware, that's going to come up in chapter 3 here. Okay. How do I solve this using substitution? Okay. Pick one of these, solve for y. Let me guess, the top one? So if we pick this and solve it for y, it's y equals, subtract the 6x, negative 6x, plus 300. And then, every place we see a y, replace it. So 12x plus y, which is negative 6x plus 300, equals 480. Okay. What do you know?
Like terms.
Like terms? 12x plus negative 6x is how I wrote it, is 6x plus 300 equals 480. We're going to subtract 300. 6x equals 180. Divide by 6, and x is 30. If x is 30, what else do you know? Plug that 30 back in to find y, right? So negative 6 times 30 plus 300. Negative 180 plus 300 is something. What is negative 180 plus 300? 120. What are these answers of 30 and 120? Dollars, yes. Because what is 30? Cost of each lesson, right? So if you have to put it in words, be able to go back and understand your context, we said X was the cost of each lesson. So each lesson is $30. What was Y? One-time fee. So the one-time fee is $120. It's one thing to be able to get the answers for a word problem. It's another thing to be able to put it back in context. What is that 30? Okay. Don't tell me that 30 is 30 lessons. Go back and understand that that is $30 per lesson. Okay. And it's $120 one-time fee. Okay. Questions there? Okay. We could continue to do more, or you guys are welcome to get started on homework. However, you've got 10 minutes. Don't waste it. It's not 10 minutes to sit and chat. It will be labeled as lesson 3.2.1 in Math Excel. And it is substitution. It may even be labeled with substitution in the title.